Hello, grade 12s, mindsetters. This is yet another great lesson that we're going to have today with me, Abraham, and of course, Lizzo. How are you doing?
I'm absolutely fine, thanks. And yourself, Abraham?
I'm supercharged. I'm ready for this lesson because I've been seeing on the page throughout that the grade 12s have been waiting for this chance. And here it is.
Wonderful, wonderful.
What are we doing today?
Well, we're going to have a look at transformations. So we're going to revise some of those reflections and rotations from grade 11. And then we're also going to be introducing a new formula based on the compound angle formula, which can help us rotate through any angle. So very exciting.
It sounds fascinating, I must say. But just before I let you go, I've been having some complaints and comments on the page about mathematics, and especially trigonometry being very tricky. What are some of the tips that you could give to the grade 12s before we get to this session?
Well, to me, trigonometry is a little bit like practicing for the Olympics. You don't suddenly start lifting weights 2 days before. It's little bits every single day. And even if you feel like you're getting nowhere, you have to believe that if you keep on working, at some point, it starts paying off, and it starts paying off big. So really important, especially now that we're getting to the sort of end of the trigonometry section, is go online, get the past papers, and do the trig. You can do all of the papers from 2008, so 2008, 2009, all the way through. And the more papers you do, definitely the luckier you'll get.
Well said, Lizelle. You know what? Those are not just trigonometry lessons and tips. They're just for life itself. Thank you very much. Take your position. Mindsetters, let me tell you about this awesome opportunity that you can have. You can enter for the Future Stars competition where you could win some really cool prizes and amazing prizes you've ever thought. There's a prize worth 10,000 Rand. So get over the page and find out details on how you can enter. Get other friends and other mindsetters to vote for you to increase your chances of winning. Remember, Future Stars competition is there to inspire you as a young person sitting at home between the ages of 16 to 21, and also helping you to believe in yourself and empower you with skills on how education can empower your life and make your life better. But otherwise, talking about education, let's get over the page and let's chat. Facebook.com/LearnExtra. Also remember, you can tweet me on Twitter @LearnExtra. Lastly, get your notes on learnextra.co.za/live. I've said it all. Now it's time for Lizelle. Let's get studying.
Right, guys. So what we're going to do to start off with is we're just going to have a look at some revision of the transformations that you need to know so far. So just making sure that you guys are up to date with everything in the grade 11 syllabus. All right. The first thing that we need to know, and actually we've known this since grade 10, is what happens, what is the rule for reflecting in the x-axis. Now guys, if you don't remember, don't stress, do it practically. So what I'm going to do is I'm going to quickly draw myself a system of axes here. I'm going to say, all right, I now am going to choose a point. Let's take the point x is equal to 2, y is equal to 3. And I'll ask myself, if I were to reflect that point in the x-axis, where would I end up? So basically what you can visualize is, imagine that this is a very, very runny ink pen, and you make a very nice wet dot over there at 2 and 3. You then take your paper and you fold it on the x-axis, and where will we see the imprint of that little dot coming off? Well, if we're reflecting in the x-axis, it will be over here. So what will happen is the x value will remain unchanged at 2, but the sign of the y value will change. So don't learn rules off by heart. Make it practical for yourself. And here it says, if I start off with x and y, x will remain the same, y will remain the same, but it will have the opposite sign. So if your point to start with had a negative y value, after reflection in the x-axis, the y value will be positive, and so on. Right, so that's our rule for reflecting in the x-axis. Now, similarly, I'm now going to take the same point and I'm going to reflect it in the y-axis. So imagine the wet dot scenario. Now, we are going to be folding on the y-axis, and the imprint will be over here, where x is equal to -2 and y is equal to 3. So what we can see is that now the y value is unchanged, but the sign of the x value changes. So if it was positive, it becomes negative. If it was negative, it becomes positive. And here is the rule. I start off with x and y, and I end off with negative x and the same y value. So those are easy ones. I think you guys have dealt with them ever since you were in grade 10, really. All right, now the next one that we look at is reflection in the line y is equal to x. Now, earlier on this year, I did a lesson on logs and inverses, and you guys might remember that if we take an exponential graph and we reflect it in the line y is equal to x, we get a log graph. So let's have a look quickly at an example. I'm going to start off, let's go back to our point. X is 2, y is 3. So the line y is equal to x is that line with a gradient of 1 going through the origin. Now what happens when I reflect in the line y is equal to x is quite simply the x and the y value changes around, right? So the x and the y value is going to change around, and here we have our rule. X, y changes to y, x, right? Remember also when we did logs and inverses, the domain of the one graph became the range of the other, indicating that the x and the y switch around. All right. Then we also looked at rotations through 90 degrees and 180 degrees. So the rule for rotating anti-clockwise through 90 degrees about the origin is that x, y changes to negative y and x, and then similarly rotating through 90 degrees clockwise, y and negative x. Right. Now, up to now, we've only learned how to rotate through 90 degrees, 180 degrees, or 270 degrees. Now, what we're going to learn today is a new formula which is derived from the compound angle formula, and that formula now allows us to rotate through any angle. So it can be absolutely any angle in the world. Now, this formula is given to you guys on your information sheet, and here it is. It says, if I rotate a point xy through an angle theta, I can calculate the new x coordinate and the new y coordinate using this formula. Now, guys, this is very important. This formula is for anti-clockwise rotation. But it's not a problem if we are asked to rotate through, let's say, 60 degrees clockwise. Obviously, that will be equivalent to 300 degrees anti-clockwise. So it really is easiest if we always go back to the anti-clockwise rotation. So let's take a little example. Let's say I've got the point x is 1 and y is 2. And I want to rotate this point 60 degrees anti-clockwise through the origin. Right. Now, because it's 60 degrees is actually a special angle, so we can ask you guys to do this without the use of a calculator. So let's have a look at how we will substitute into our formula. I say to myself, right, I'm starting off with x is 1 and y is 2. To get the new x coordinate, I take the original x coordinate, which is 1, and I multiply it by cos of my anti-clockwise angle of rotation, and in this case, it's cos 60. But that's not all. Then I put in a subtraction sign, a minus. Then I take the original y value. The original y value was 2. and I multiply with sine of the angle. So the sine of the angle will be sine 60. Now, I know that you guys will all be using your calculators, so let's do 1 cos 60 minus 2 sine 60 on the calculator. Okay, so that's 1 cos 60 degrees minus 2 sine 60 degrees equals, and there is my new x coordinate. Depending on how, you could be asked to give it in simplest third form, in which case you'll give it like this. If you were asked to give it to, let's say, 2 decimals, you'll just press the third to decimal button, and that works out to be minus 1,23 approximately. Right, now that is then my new x coordinate, so let's write that in, negative 1,23. So you'll just be checking the instructions telling you how you need to round. Okay, now we need to find the corresponding y coordinate. So now I say, for the y coordinate, I take the original y value, 1, times the cos of the angle, plus the original x value, the original y value was actually 2, plus the original x value times the sine of the angle. And once again, you will put that into your calculator, and that will give you your coordinate after rotation. So it needn't be a special angle, like 30, 45, 60. It can be absolutely any angle. It can be 23,3. Another thing that's interesting is, in case you forget your rotations through 90 degrees or 180 degrees, you can always use this formula. And this formula is on your information sheet. So if you had forgotten what is the rule to get to the new coordinate after you've rotated 1, 2 through, let's say, 90 degrees, you can calculate the new coordinate using this formula and quite simply just substituting in your 90 degrees. Right. So that's a quick little overview. Abram, what's happening on the page? Is everything going well?
So well, I've got mindsetters like Kilavia was saying. I'm enjoying the show, and holla to all the mindsetters and all the future stars. Keep up the great work, mindset.
Fantastic. All right, well, let's then have a look at our first question. Now, very often, the question will combine the stuff that we've learned in grade 11 with some of the things that we're learning in grade 12. I think our first question is mostly grade 11 revision, but there's nothing wrong with that. So the question says, in the sketch below, the shape A was created originally, and then several transformations were carried out. So here is the shape A. I'm just going to highlight it. So there's shape A, and it was then transformed to B. We'll make that in a different color. Then we've got D over here. Then we've got E over here. Now what I can see is that E is smaller than the original shape. And then finally, let's just highlight C as well so that we can see where they are. Okay, so this diagram was given to us, and we were then asked the following questions. Right. The first question says, describe the following transformations using mapping notation. So they want to know, how did I get from A to B? Now, always bear in mind what I said to you guys about folding on your axes. Can you guys see that if I were to draw shape A over here in wet paint and then fold it on the y-axis, I would get shape B over here. So what is this? This is a reflection in the y-axis. Now, if they asked us to describe this transformation in words, we will write out reflection in the y-axis, because that's what happened. However, if we have a look at the question the question says that we must use mapping notation. Now, you can very easily, boys and girls, just choose a point. Let's take that vertex over there. This is x is 1 and y is 2. Now, its friend on this side is x is minus 1 and y is still 2. So if we'd forgotten the mapping notation, that's not a problem. We can say that xy, my original point, changes to negative x and y. And why is that the case? Because what we saw earlier, and if you look at that point when we reflect in the y-axis, it is the x value that changes sign. So if it was positive originally, it becomes negative, but it doesn't matter. This is the general rule for the mapping notation. Now it's almost time for us to take a break, so I'm just going to let you guys look at the next question. The next question they want to know from us, how did I get from B, that shape over here, to D? So while we're taking a break, I need you guys to think for me what happened from B to D. And I think we'll leave it at that. So we'll leave it at from B to D for after the break. Have a look, see if you know what happened there. Remember, it doesn't need to be a reflection. It can also just be a translation. So you can say 2 up, 3 down, or 2 left, 3 down, or something like that. Abram, time for our first break.
Cool stuff.
Time flies when you're having fun.
Yes, and also I should tell the mindsetters we've posted the graph, so you don't have any excuse to get working and not to work with us. So make sure that you get on the page, check out the graph, and download your notes. And let's keep working. See you right after the break with the right answer. Welcome back, Mindsetters matriculants, particularly joining us right now in this session. We're learning a lot about transformation and trigonometry. I hope you are also learning as much as I do. So, if you're learning, let's get on the page. Let's chat about it. Any questions that you're having and any questions that other Mindsetters are having, let's help one another. We are on facebook.com/learnextra, or you can tweet me at LearnExtra. Make sure that you download your notes also on learnextra.co.za. Lizzo, take it away.
Right, so before the break, the question that we posed to the students was, describe the transformation using proper mapping notation, and now we want to know how we got from B to D. Now, for me, it always helps if you have a shape to get one point of particular reference. So I'm going to have a look at that point over there. I'm going to say, all right, if I have a look at the translated shape, can you see that what I've done is I've moved 1 unit to the left, right? So to get on the right X position for the translated shape, I had to move 1 unit to the left. So that means I go from X and Y to X minus 1. So if we're translating a point, minus means left, plus means right. And for the Y values, minus means down, and plus means up. So we've gone 1 unit to the left, but we've also definitely moved down. And to get to the correct Y value, I've got to jump 1, 2, 3, 4, 5 positions. So that is Y minus 5. Remember, boys and girls, if we ask for it in mapping notation, you do have to do it like this. Alternatively, we can ask you to give your answer in words or just to describe, and then you'll just say 1 unit to the left and 5 unit downwards. Abram, did anybody get that?
No one got it.
Maybe they just didn't have enough time to look at the graph properly. Right, so that's question A and B, or question 1 and 2. Let's have a look at our next question. So we are still dealing with the same graph. Now we are asked to describe something in words, and they want to know from us, how do I get from A all the way over here to C? Now, this can actually be quite a tricky one. It really can be quite tricky. Now, the first thing that we need to do is we need to reflect this shape in the x-axis. So let's have a look. If I reflect the shape in the x-axis, I'm going to end up over here. Let me just draw it properly, like something like that. Yes, so that's 2 units away and 2 units away. So the first move is to reflect it in the x-axis. The next move is to reflect it in the line y is equal to 3. Now, we don't only reflect in the x and the y-axis and the line y is equal to x. Have a look there. That is the line where x is equal to 3. Now, if I reflect in that purple line, I will now end up with a shape that looks, oops, not like that. It doesn't change shape. I must just draw it properly. So we need to go all the way there. All right, so now I can already see that my shape is in the right position. It's got its little pointy bit facing in the right direction. Now all I need to do is I need to move this shape until it coincides with the position of C. So let's have a look. I'm going to move it upwards. 1, 2, 3, 4, 5, 6 units. Right? So I'm reflecting in the x-axis, and then I am moving it up by 6 units. So quite a complicated one, that one, but there it is. Right. Again, on the same story, they're asking us for the area of shape C. Now, guys, you don't have to use a formula for this. This is the reason why there's little blocks behind it. And what you guys must be able to see is that it is 1, 2, 3, 4, and these 2 bits make up another 1 square unit. So the shape of C is 5 units squared. Alternatively, you could have also seen it as a combination of a square and a triangle. So for the squares area, you'll say side times side. So that'll be 2 times 2, which will give you 4 for that area that's colored in. And then for the triangle, it's half base times height, or base times height over 2. And the base of the triangle is 2. The height of the triangle is 1. Divide that by 2, and that gives us 5 square units. So if you didn't have the blocks, which were conveniently given to you, then you could have calculated it just as a combination of a square and of a triangle. Abram, how's our students doing so far? Are we still following?
They're still following, and they say I should highlight them, the matriculants that are listening. I'll keep on doing that throughout the show, Mindsetters. Let's learn more.
Right. Now, guys, the next thing that we're having a look at now is enlargement factors. Now, I haven't dealt with this before, so let's quickly just look at it. If I have a point xy, and I enlarge that point by a factor of, let's say, 2, right? Then what will happen is that the enlarged will become 2x and 2y, all right? But now I want to show you guys quickly what happens to the area. So I'm going to extend my page over here. So let's say I have a shape over here. Let's make it a square. And we'll say this coordinate is 1 and 1. This coordinate is x is 2, y is 1.
And I have a quick question for you, Lizelle.
Absolutely, far away.
from Silo Arthur saying, can you please explain how you got to C from A again? I didn't get it. I think my answer is Y and X.
All right, we'll go back to that in a second. Let me just quickly finish here, and then we'll go back to that. Now, let's say I've got this square over here with the coordinates as shown. If I now enlarge by a factor of 2, I'm just choosing 2 for now, what is going to happen is that every single one of these coordinates are going to become multiplied by 2. Now, I'm going to draw it on a separate system of axes. So this coordinate that was 1 and 2 will become 2 and 4. This coordinate that was 2 and 2 will become 4 and 4. Same over here, multiply by 2, 2 and 2, and multiply by 2, 4 and 1. Now, I might not have gotten the size quite right, but if you guys look at this square that I've drawn here, do you guys see that each side length is 1 unit? So this side is 1, that side is 1. So the area of this square is 1 times 1, right? So the area of this square is 1 unit squared, right? Okay, so let's just go back to that quickly. What happens to the sides? The sides were 1, 1, and 1, okay? The area is 1 unit squared. Now let's have a look at my enlarged shape over here. What happens now is that the side lengths are 2, 2, 2, and 2. So the side length has doubled, right? Which will mean that the area is now 2 times 2, which is 4 units squared. What am I trying to show you guys here? If I enlarge by a factor of 2, the sides of the figure will become twice as long, but the area will be 4 times bigger. If I enlarge by a factor of 3, the sides will be 3 times as long, but the area will be bigger by a factor of 9. So remember, an area is a side times a side, so we're dealing with the enlargement factor squared. So even if you don't have a sketch, if I say to you, you've got a figure with an area of 10 square units, you now enlarge by a factor of 2, right? You say to yourself, right, 2 times 2 is 4. So even though I'm enlarging by a factor of 2, the area will be 4 times as big. So the area will be 40 square units. That's a very important thing to remember. And the reason I'm telling you guys this is because of our next question. The question now says, the first question was, find the area of shape C. So we managed to do that. We said that it is 5 units squared. All right, now they say, hence determine the area of shape E if shape E is enlarged through the origin by a factor of 2 over 5. Now, because 2 over 5 is actually less than 1, we're not really enlarging, we're actually decreasing, but that's not the issue. So now I say, right, my original area was 5, but if I enlarge by a factor of 2 over 5, the area of the actual shape is going to be 2 over 5 units squared multiplied by the original one. So this gives us 5 times 4 over 25, if I square that out, and I can say 5 goes into 5 once, 5 goes into 25 5 times. So that will be 4 over 5 units. So units squared, rather. So very, very important. If I enlarge by a factor of 3, the area will be 9 times bigger. If I enlarge by a factor of 10, the area will be 100 times bigger. And that's because area is in 2 dimensions, guys. Very, very important. Abram, are our students understanding that? I'm hoping so.
They are, and also I've got the right answers too.
Oh, you got the right answers. Well, there's absolutely no better proof that somebody knows what's going on than a correct answer.
Mm.
Now, before we go to the next break, let's just have a little look at our next question. It starts with a story. It says that Cuba joined the Olympic Games in 1900. The Cuban flag is shown on a Cartesian plane below. Right. So let's just have a look at the Cuban flag. All right. So we've got our vertices, A, B, and C, and they appear to have moved a little bit, but that's fine. I'm just trying to think how we're going to do this. I think we're going to do it like this. I'm going to do my own new system of axes. Basically, we're looking at point A, which is x is minus 4, y is minus 1. So we put that there. X is minus 4, and y is minus 1. Lovely. So what they're talking about is this triangle, but you guys can see my triangle seems to have moved. All right, then they tell me that the coordinate of B is x is minus 3 and y is minus 5. So x is minus 3, y is minus 5. Let's make it over there. And finally, C, x is minus 1, y is minus 2. So let's put it over there. Okay, so they're basically referring to the triangle in the Cuban flag. Usually with a question like this, we'll give you another picture apart from the one with the flag on. So basically we're talking about 3 coordinates. Right. So that's what we're going to be talking about. They're talking about the following things that happens to my points. They are reflected in the x-axis. They are translated 4 units right and 2 units down, and then they are enlarged by a factor of 2 through the origin. So give that some thought during the break, and we're going to see what they're asking us about this flag.
Well said, Lizelle. Now, let me just highlight the mindsets that have been waiting for me to highlight at them, the grade 12s that are listening, that are watching. Jabu Bafana, West Kajwa, Hala at you, and also Lebogang, Chamster, Monaise. Hope you're enjoying the show. Hala at you guys, and let's keep on chatting over the page, and let's help one another. See you right after the break. Welcome back, matriculants. We're still learning more with me, myself, and Lizelle. Are you still having fun?
We're still having lots of fun here.
I have a question for you.
Yes.
It's from Nontlanta Precious Mateula. It says, hi, I have a question. Would it be easier to just rotate A by 180 degrees to get to C?
You won't get directly to C, but you can start with a rotation of 180 degrees. Right. The best thing to do would be to take one of the points on A and see what happens when you put it into the rotation formula. That will be my tip. Unfortunately, I can't go back to that question because we've got so much that we still have to get through, but that would be my advice. Right, guys. So what I've done in the break is I've drawn us a little picture of the triangle in the Cuban flag. That's all that they're really worried about, is in the Cuban flag there's a triangle, and the triangle has vertices A minus 4 minus 1, B minus 3 minus 5, and C, x is minus 1, y is minus 2. So it should actually be a little bit lower, but that's fine. Then they tell us that the following is being done to our triangle. The first thing that we're doing is we are reflecting in the x-axis, right? That is then followed by a translation. A translation just means to move, and we are translating 4 units right and 2 units down. And then finally, we are enlarging, doing an enlargement by a factor of 2 through the origin.
All right, when you're done with that, I'd like you to go back a bit to a certain question. It seems like there's a mistake that you've made.
Oh, really? I'll deal with that in a minute. Yes, which one is
All
that?
right.
The A to C one?
No, in the D question, she says you made a mistake and said D is 2 to 1. The enlargement factor of 2, it is 4 to 2, not 4 to 1.
I'm not exactly sure which one you're referring to, Abram. I'll have a look. I don't think so.
All right, you can continue. You can.
All right. The enlargement factor in that question D was 2 over 5. So the area would have changed by 2 over 5 squared. All right. I'm going to carry on.
Yes.
Because I'm pretty sure that that was correct, but nonetheless, we don't want our students to lose interest in this question. And let's just go back to my diagram over here. Right. So I reflect in the x-axis. Then I translate 4 units right and 2 units down, and then I enlarge by a factor of 2. Now, what they want us to do is now take all 3 of these translations or transformations and put them down into one rule. Now, what I'm going to do is I'm going to take it step for step from one to the other, and I'm going to see where we end up. Right. Firstly, let's start with any point xy. I am now reflecting it in the x-axis. Now, we've spoken about this many times before. What happens if I reflect in the x-axis? The sign of the y value changes. So my first little bit can be represented as x and negative y. I think we've spoken about that quite often, all right? So my x value stays the same, but my y value changes sign because I'm reflecting in the x-axis. Right, so I've represented the first step. Now I'm going to take my x and negative y, and I'm going to apply the next transformation to it. Now it says I'm translating 4 units to the right and 2 units down. So what is going to happen now is, because I'm going 4 units to the right, this becomes x plus 4. Remember, I'm working from this one to the next one. And 2 units down now becomes negative y, which I had before, minus 2. So I've now dealt with the next instruction. I've translated 4 units to the right and 2 units down. Finally, they want us to enlarge by a factor of 2 through the origin. Right, so we're enlarging by a factor of 2. That means that my current x value, which is now x plus 4, will be multiplied by 2, and my current y value, which is negative y minus 2, will be multiplied by 2. And if I now simplify that, I get 2x plus 8 will be my new x value after all 3 of these transformations have been done. And my new y value after all 3 of the translations have been done will be minus 2y minus 4. So it's very difficult to do this all in one, but take it step for step. Say what happens from the one to the next, what happens from the one to the next. And I now have a general formula that describes all 3 these transformations. Right. So I can now use this little formula that I've got over here in yellow to get the new coordinates. And if I'm not mistaken, that is my next question. So let's just get back to there. Back to our Cuban flag. And right. Okay, I can't seem to find the question there, but the first question did say to describe the transformation. So it's going to be x and y, which changes to 2x plus 8 and negative 2y minus 4. And remember, guys, you don't have to get directly from this point to that point. You can do every transformation separately. Now, the next question, as far as I could remember, and I'm still looking for it, I don't seem to be able to find it, but I know what it is. The next question asked me to now give the new coordinates of A, B, and C after all three these transformations have been done. Now, guys, that is not difficult at all. All I need to do is write down those original coordinates. Now, if I look at A was minus 4 and 1. Right. Now, to get the new x coordinate, after these three transformations have been done to A, I'm going to quite simply substitute minus 4 into the place of x. So I'm going to get 2 times minus 4 plus 8. So the new coordinate of A after these transformations, let's call it A dash, will be 2 times negative 4 plus 8, which is 0. Right. Then similarly, to get the new y coordinate, I'm going to substitute 1 into the place of y. So I'm going to say negative 2 times 1 minus another 4 is negative 6. So once you have the formula, it's actually pretty straightforward. Let's do the same thing quickly with B. Our original coordinates for B, I'm not going to do them all three, but we can at least do A and B. Our original coordinate for B was x is minus 3, y is minus 5. So now, to know the new coordinate of B after these transformations have been done, I'm going to substitute minus 3 into the place of x in my general formula. So I'm going to say 2 times minus 3 is minus 6. Minus 6 plus 8 is 2. So the new coordinate, x coordinate of B is 2. And then similarly, I'm going to take the y coordinate and I'm going to say 2 times negative 5, which is 10, and 10 minus 4, which is 6. So that just goes to show that once you have a general formula, you can just apply it. I know that one of the other questions dealt with the perimeter of this figure. Now, if you guys have a look, they asked us, give the ratio of the perimeter of ABC, that's my original, over the perimeter of my new figure. Now, the reflecting in the x-axis and the translation doesn't change the size of the figure at all. However, the enlargement does. So the translated figure will have a perimeter twice that of the original figure, right? So that's perimeter. However, if they had asked me about the area of ABC, my original triangle, divided by the area of my enlarged triangle A dash B dash C dash, if this one was 1, this one would have been 4. Because remember, guys, as I said to you guys earlier, if I enlarge by a factor of 2, the area will be 4 times as big, 2 squared. The perimeter, however, is just twice as big. Right. Guys, we still haven't done another example of rotating through any angle. So I'm going to go to our next example, and we're going to practice some of our grade 12 work over here. Right. The question says that we have a point S, and S is x is minus 1, y is 4. And it says that S is rotated through an angle of 120 degrees, anti-clockwise, about the origin as shown in the diagram. And what they want from us is to determine the coordinates of S dash. Right. So we need to determine the coordinate of S after rotation 120 degrees anti-clockwise about the origin. Right. Abram, do our students seem to know what to do?
Oh yes, there's Tulane Keith in the mind is saying, I'm super understanding. Keep it up, Mindsetter, and let's learn more.
Right. So let's have a look at our formula. I think that would be the first thing that I'm going to write down. I'm going to say translating anti-clockwise, my original x and my original y will change to x times the cos of the angle minus y times the sine of the angle. This portion will give me the x coordinate. Then the semicolon and the y coordinate will be given by y cos theta. And now the sign is plus and x sine theta. And remember, guys, I said earlier on, if they had said to you 240 degrees clockwise, all you need to do, if you want to keep on using this formula, is say, all right, so 240 plus what? Gives me 360. So that would be 120 degrees anti-clockwise. Right, so I'm going to go straight ahead and substitute into my formula. My original x value is -1. My original y value is 4. So now, to calculate my new x coordinate, I'm going to use my original x coordinate, which is -1, times the cos of 120 degrees minus my original y coordinate, which was 4, and then the sine of 120 degrees. And this portion is going to give me my new x coordinate. So we do need to show that substitution at least. So let's show the substitution for the y coordinate. Now, my formula says, take your original y value, and my original y value was 4. Multiply it by the cos of the angle of anticlockwise rotation. So that is cos of 120 degrees. And then a positive sign. But now, it's my original x coordinate, so that's actually -1. And multiplied by the sine of the angle of rotation, that's sine 120. Okay, so boys and girls, even if you have to do 90 degrees, 180 degrees, if you've forgotten your rules, this is a very easy way to make sure that you get the right coordinate. Now, if I told you guys to do this without a calculator, I would have expected you guys to do the following step. You would have had to say to me, well, cos of 120 is 180 minus 60, which is in the second quadrant where cos is negative, so then this would have become minus minus, in other words, plus 1 cos 60. So this is if it was without a calculator. And mostly if it's angles like 120 that can be taken down to a special angle, we will ask you to do it without a calculator. Then sine of 120 can be written as sine of 180 minus 60 degrees. However, in the second quadrant, sine is fortunately positive. So this becomes minus 4 sine 60. And then similarly, over here, cos of 120 is cos of 180 minus 60. Second quadrant, cos is negative there. So this is actually going to become negative cos 60. Sine 120, sine is positive in the second quadrant. I'm just writing that plus and that minus sine 60. And then you will go absolutely straight ahead and just put it into your calculator. So we're going to go for the first one, cos 60 minus 4 sine 60. So let's do it. Cos 60 minus 4 sine 60. And depending on whether they ask us for our answer in simplest third form or in decimals, we'll go right ahead and do that. And the same over here. We're going to say minus 4 cos 60 minus sine 60. So boys and girls, that is the basics on rotation through any angle. The formula that I've dealt with today is the anti-clockwise formula. However, if you are given a clockwise rotation, just ask yourself, what do I need to add to give 360? So in other words, if I were to say 90 degrees clockwise, you'll say, okay, what do I add to 90 degrees to give me 360? That's 270. So that is then equivalent to using 270 degrees in the anti-clockwise direction. Guys, there are questions on this that does get harder, and when we get to the point where we start working through past papers and things like that, we are definitely going to deal with them. One of the questions, and you guys might want to start looking for questions like that, is if I give you the original point and the final point, and I actually ask you for the angle of rotation, that can get quite tricky. Abram, I think that is more or less all we have time for tonight. I'm going to give it over to you to wrap up for us.
All right, before I wrap it, there's just a great discussion going over the page, and I'd like you to just view a bit. Person is a new mindset that has joined it, saying, I really understand certain things, but I just want this one trick that will help me pass my maths.
You just want this one?
One trick that will help me pass my maths.
There aren't any easy tricks. The trick is to practice and practice and practice. Keep watching us. That's the only advice that I can give.
Well said. On that note, I'd like to thank all the mindsetters that have tuned in, especially Silo, who's been helping other mindsetters over the page, and also other mindsetters like Nonta and Pressure, saying thank you very much for helping me, mindsetters. And I should tell you that mindsetters, we have the details for the Future Stars competition over the page. So get on the page, get some details, and learn more. I like how you've been also responding in terms of helping one another. That's what we need, mindsetters. And that's what Lizelle also is happy about. When you are learning, let us know how are you doing things. And otherwise, mindsetters, I just want to say thank you very much for tuning in. The mindsetters that are on the page and the mindsetters that are always on the page. Thank you very much, mindsetters. We love you all, and we just want to thank you. Lizelle, we've done a great work. I think we couldn't have done better than this.
Well, I hope that it's helped, but keep watching.
Keep watching, mindsetter. And last highlights for the matriculant called Wilshed Matlase Maponyane. Thank you too for watching the show. From me, I just want to leave you with these wise words. Never ever stop believing in yourself, because when you stop believing in yourself, no one will believe in you. Love you. Bye.